Good evening, Accelerated Math. Don't start writing yet. Today's mini lesson is solving ratio problem strategy number 1, called proportions. That's the name of the strategy. But I do not want you to label your next page as that. We're going to learn 4 different strategies the next few days. Today's just the first one. And we're going to kind of look at a lot of the same problems over and over to do that. So what I really want you to do, take your next free double page, like where you can do a back of a page and a front of a page. And I want you to label the big double page as solving ratio problems 4 strategies. So today I'm just going to show you the first, and we'll keep coming back to this page. And then actually take your double page and divide it into 4 giant sections. So half a page, half a page, half a page, half a page. After you have set your page up like that, then unpause, close your notebook, and think along with me. Okay, so we're going to talk about ratio problems for the next 4 days. You've actually already solved a ratio problem that I gave you before you even knew what a ratio was, right? A snack mix recipe uses a ratio of 5 scoops of granola for every 3 scoops of candy. How many scoops will he need to make 6 batches? I think he made 12 batches. Sorry about that. How many will he need to make 12 batches? And so in that case, right, we had a ratio of 5 to 3, granola to candy, 5 to 3. And he just kept making sets of that, right? He did like 1 batch, 2 batches, 3 batches, and so on until we made 12 batches to see how many scoops he needed. And so kind of the fast way to write that would have been, well, he made 12 batches of each ingredient. And so we got our equivalent ratio that way, 60 scoops of granola and 36 scoops of candy. That's how we did that. And so we're going to use a strategy like this today to solve some new ratio problems. Let me do an easy I do and then a harder I do. So easy I do. The ratio of boys to girls in a class is 3 to 2. If there are 12 boys, how many girls are there? So in this case, so my first strategy is called a proportion. And a proportion is going to be 2 equivalent fractions or 2 equivalent ratios shown as fractions. So what I do, I set one up. So I start with this ratio of knowing there's a 3 to 2 boy to girl ratio. This is boys, girls. And in the question I'm told there are 12 boys. So in my second ratio, I know there's 12 boys, but I do not know how many girls there are. I'm trying to figure this out. So what I'm going to do is just like I did in that problem a minute ago, is I'm just going to say, all right, well, if you think of these as groups or batches almost, like with the candy and the granola, if I have 4 times as many boys, then I must also have 4 times as many girls. So there must be 8 girls. If I'm going to keep the same ratio, I've got to multiply both ingredients in the ratio by the same thing. So this thing right here, this 3 over 2 equals 12 over 8, this is a proportion right here. It's 2 equivalent ratios shown as fractions. If you wanted to think about how this worked, I took my 3 boy, 2 girl ratio, and in order to get 12 boys, I had to make 4 sets of this, like 1, 2, 3 boys, 4, 5, 6 boys, 7, 8, 9 boys, 10, 11, 12 boys. And every time I have 3 boys, I have 2 girls. So the times 4 is just like making 4 sets of that ratio. And then there were 1, 2, 3, 4, 5, 6, 7, 8 girls. That's how that worked. That's not really part of the strategy, but that's just to let me kind of show you how that worked. This is a proportion right here. Let me do another one that's a little harder. They're not always quite that easy. So at Discount Books, 4 paperbacks books cost $14. How much would 7 books cost? So I've got this I'm going to show you how to use the proportion strategy, so I better write that down. I've got a proportion or a ratio of 4 books to $14. And I'm going to use that ratio to figure out how much 7 books would cost. 7 books would be to how many dollars? So I'm trying to figure out what goes here in my proportion. So what's harder about this one is I can't just, like the last one, I can say, oh, 3 times 4 is 12. Here, 4 times what is 7? That's not that obvious to me. I can't just say, oh, I know what that is. Because in this case, it's 4 times, it's more than 1, but it's less than 4, or less than 2, because 4 times 2 would be 8. So I have to figure out what to multiply by before I can multiply by that same thing down here. So to use my strategy, so what I'm really asking myself, I'm like, what number times 4 equals 7 to do this? And so I can reverse that. Excuse me, and say, well, the reverse of that is 7 divided by 4. Ooh, sorry about that. 7 divided by 4 is what number? That's going to give me that question mark. The inverse of multiplying is dividing. So I can figure out what this is if I do 7 divided by 4. So let me pull up my calculator for that. 7 divided by 4 is 1, and that's 1 3/4, 1 75/100. So 4, and that makes sense, right? 4 times 2 would have been 8. That's a little less than 2. So 4 times 1 75/100 gives me 7. So I also would multiply by that same thing down here to see how much the cost would be. 7 books would be 1 75/100 times 14. And it would be $24.50. So now when I end up with my work erased, this is my proportion. And since this is a problem involving money, I might even add the 0 here to show 24.50. So this is a proportion right here, 2 equivalent ratios. And so a lot of times the work gets shown with it. This was 1 75/100. So this is 1 75/100. Okay, let's do one together. So the total number of students enrolled at Berkmar Middle School is 1,400 students. The ratio of boys to girls is 3 to 4 for the school. How many students are boys and how many students are girls at Berkmar Middle School? All right, there's a lot more going on in this we do than in any problem I showed you so far. So let's, first of all, title this section Proportions. Right? So in my proportion here, let me write that so you can read it. I'm sorry. So this is new. Proportion. So when I set up my proportion, remember what I'm setting up in a proportion is 2 equivalent ratios shown as fractions, 2 equivalent fractions essentially. The ratio I'm given is the ratio of boys to girls is 3 to 4. 3 to 4 boys to girls. So what's hard about this one is the other number I'm given is this 1,400 students at the school, right? But that is not either one of my numbers here. That's not how many boys are at the school, and that's not how many girls are at the school. That is how many students are at the school. They come in this ratio. So what I'm really given is total number of students. So in my ratio, if I think of the part to whole ratio rather than the part to part ratio, I need to know this ratio shows me 7 kids. Right? In every 7 kids, 4 are girls, 3 are boys. I need to know that same ratio for 1,400 kids. So I need to know what am I multiplying 7 by to get to 1,400. How many sets of those 7 kids am I going to have to get to 1,400? I'm going to pull my calculator back up. And 1,400 divided by 7 is 200. So I have 200 sets of 7 kids to get to all these kids, right? So I have 200 times as many kids, and I keep the ratio. That would also mean I had 200 times as many boys and 200 times as many girls. So 3 times 200 is 600. So if I had 1,400 kids, 600 of them would be boys, and 800 of them would be girls. These are equivalent ratios. And if you notice, that is 1,400 kids, right? I have 600 girls and 800 boys. That is 1,400 kids. So in all, that's my each. This right here, this is the proportion right here. It's 2 equivalent fraction ratios just like that. So if you need to go back, and these are kind of complicated, if you need to go back and see this again, please do. Make sure you understand the strategy that I used to get from here to here. Understand the strategy that I used in the other 2 examples as well, and then we'll move on to another strategy tomorrow. Good work. See you then.